From the Times and the Sunday Times, this is The Story. I'm Manveen Rana. That's probably a sound you don't recognise. And for good reason. It's supposed to be extinct, or at least it was, until an American biotech company got involved.
Colossal is the world's first de-extinction company, and we combine de-extinction with species preservation, and our goal is to make extinction a thing of the past.
It's a big goal. In fact, a colossal one. But this company claims it can reverse the extinction process and bring back species that died out thousands of years ago.
We're trying to develop these new techniques in order to save animals, in order to bring back animals that, in some cases, were our fault that we don't have them any longer.
The company claims to have had its first big success. While they're still working on bringing back, or de-extincting, the dodo and the woolly mammoth, they now claim they've succeeded in recreating the dire wolf.
One of the things that's absolutely critical to ecosystems is predators. And so we felt that it was very important for us to bring back the dire wolf.
Dire wolf. Dire wolf.
The dire wolf is the first species that we're bringing back at Colossal.
The dire wolf. You might not have heard of them. They were last seen roaming the American plains around 10,000 years ago. Unless you're a Game of Thrones fan, in which case you'll know them as being part of the menagerie of semi-mythical creatures that act as pets and sidekicks to the main characters.
You want to hold it?
Their mother's dead.
Run to the litter. That one's yours, Snow.
But are the large white wolf cubs that American scientists have created any more real than the ones on Game of Thrones? How do we know what an extinct species was really like? Or is the process of de-extinction about to herald a brave new world? The story today. Dead as a dodo? Not anymore. Tom, you know the drill. Would you mind just reintroducing yourself because it's been far too long?
My name is Tom Whipple and I am a science writer at The Times.
It's not often I get to start an interview like this, but just tell us a bit about Romulus, Remus, and before you head off into Rome, Colossal, and how you first heard about them.
Romulus, Remus and Colossal are dire wolves. The last time a dire wolf padded around the tundra of North America terrorising the megalodons was when megalodons were around. It was 10,000 years ago at least that these things existed in North America. But now, with some caveats we'll get onto, they're back. They have been de-extincted by Colossal Biosciences, which is a for-profit company which is looking to control and reverse extinctions. It's looking to give humanity the tools to bring back animals.
I love that de-extincted has become a thing. Just describe what they look like.
Look, they're really cute. They are, at present, these are not things that would strike fear into the heart of a bison. They are puppies, and they look like puppies. They are shocking white, and that's obviously part of it, because the dire wolf is bigger than a normal wolf, more powerful than a normal wolf, and whiter than a normal wolf. But they just look, they're little bundles of fluffy cuteness that are in an undisclosed location in the US, growing up to be dire wolf-ish things.
Tell us a bit about the company.
I first came across George Church, who is a Harvard professor who I very much like.
Hello, Tom. How are you? What we're trying to do is build up a set of tools that puts the brakes on extinction.
He is a very colourful character, and he is behind Colossal Biosciences.
I think the investors are trying to see new technologies, and I guess that's what I'm trying to do too.
He co-founded it along with a very rich American tech bro, probably wouldn't call himself a tech bro, but he's been the big force. I first came across him over a decade ago when he was talking about de-extincting the mammoth. We have the mammoth genome. Mammoths died in cold places. DNA degrades quickly, but mammoth genomes maintained in the permafrost.
This is the big woolly mammoth.
The big woolly mammoth, which overlapped with humans. And he says, we've got these, we've got the genomes, and he says we can bring these back. And wouldn't it be a marvellous thing? And in fact, in 2017, in the Times, there was a story no less saying that Harvard scientists, the authoritative Harvard scientists, are going to bring back the mammoth within 2 years. And the astute amongst you might note that 2 years has passed and more since 2017, and we don't yet have the mammoth. But that came once again from George Church, and indeed from me.
What did you make of him when you first came across him, when he told you he was going to bring back the woolly mammoth? What did you make of the man?
He's really engaging. He's a very enthusiastic guy. He looks like a scientist should. He's like scientist Father Christmas. He's got a big beard. Whenever I Zoom call from him, he's in his lab doing things. He's been a big genetics pioneer, but he's reached a stage of professordom where he's not playing the same game as everyone else. I don't think he particularly cares about maintaining the rigid academic path. He has his lab, he has his life, and he's been at the forefront of so much of the genetics that has really transformed what we do in the 21st century. And he has his passion, and they're mammoths.
So this really is a man who is at the forefront of the science around DNA. As you mentioned, this company, this private company, Colossal Biosciences, was started by the scientists, but also by a tech bro. Tell us a bit about him. Who is he, and why is he part of this gig?
So he is Ben Lamb. He's only in his sort of early 40s. He is an entrepreneur. He's the sort of the Californian archetype where their business is business. Their business is moving, breaking things, founding lots of companies. And then he came to this idea of doing something really quite big. And George had been plugging away with this, but, you know, what he really needed was money. And there was an idea that maybe this could be something that would do something for the world, but also come up with tools that can end up being quite profitable. And Colossal Biosciences now has hoovered up quite a few of the scientists in this field, I suspect given them rather better terms, and started really applying itself to these problems.
Just explain that, because I suppose people listening will be wondering how on earth you make a profit out of bringing back a woolly mammoth. How does the business side of this work?
To be perfectly honest, it's slightly opaque. You can easily think of ways to make this profitable if you go into partnership with Mauritius and give them the dodo, then there'll be tourism revenue in that. If you decide to create a sort of Ice Age version of Jurassic Park in Siberia, complete with dire wolves and mammoths, then there is money in that. But look, to be confirmed quite how they're going to start really monetizing this, but investors clearly think they do because the company's worth billions. We have the full mammoth genome pretty much. We have the full direwolf genome pretty much. It's been extracted from skeletons, from tooths, reconstructed in fragmentary bits. That is not enough to bring one back. We can't synthesize, just from the code, we can't synthesize a genome and somehow get that to become a creature. So what they've done with the direwolves and what they're planning on doing with the mammoths is find a similar creature and start with that. So with the mammoths, it would be elephants, and with the direwolves, it is wolves. And they started with the grey wolf genome in this case, and they compared it to the direwolf genomes that we have, and they looked for the bits, basically the bits of direwolf that aren't grey wolf. They looked in the genome for those. They looked for those that might give it the characteristics that we think of as direwolf. white coat, bigger, more powerful, stronger, all these things. And they looked for the bits actually which seemed to be really quite strongly associated with the direwolves. And they changed them, and they changed 20 of them on 14 genes.
We have cells growing in a dish in a lab that belong to a gray wolf. And so these have gray wolf genomes. Now we've decided which part of that genome we want to change. So one at a time, we take our gene editing tools and we go into that cell and we cut out the bit of DNA that looks like a gray wolf and paste in its place the DNA that looks like a dire wolf.
And then so they took this edited gray wolf genome with these 20 changes, and then they put it into a cell, and they used techniques similar to those used for cloning Dolly the sheep all that time ago to implant an embryo that had been edited this way in a dog. And now this is why I've had people say, look, this is direwolf-ish, or it's basically a genetically modified grey wolf, because there are millions of genetic differences between a grey wolf and a direwolf, and this has just changed 20 of them.
Is it actually a direwolf? It's an approximation of what it looked like. It's clearly not the same thing. It's genetically modified gray wolf made to look something like what we think a dire wolf looked like.
Just make sense of that for us, because a lot of people will have come across the expression that if it looks like a duck, if it swims like a duck, if it quacks like a duck, it's pretty much a duck. I mean, would these direwolves look like direwolves? Will they act like direwolves? Will they be as ferocious and as big as direwolves? Is it just the genes that are different, or will some of those characteristics not really play out in the way that they would with an actual direwolf?
The short answer is not a clue. The longer answer is, in this experiment, and they haven't released exactly what they've done because it's a commercial secret, but we're assuming they're changing the genes that make them look like the skeletons that we know of. Now, there will be genes in there that determine their behavioural characteristics. We're all creatures of our genetics. Everything is inherited to a certain degree. That which isn't inherited is nurtured. So these direwolves are not being raised by direwolf parents. They're not growing up in a direwolf herd. They're not learning the things that direwolves learn from each other. So the nurture element of them is definitely not going to be direwolf. The nature element isn't either, because we don't know what it is to be a direwolf, and we don't know psychologically what genes to change to do that. So it might well be that some of these genes they changed do indeed cascade down into psychological effects, but it may also be that these things think they're normal wolves, and probably that doesn't matter hugely, because I would suspect as a direwolf living in Alaska, your life and your instincts probably aren't that different to a normal wolf living in Alaska. But as a mammoth living in Alaska, I think probably you would be psychologically rather different to a mammoth living in Africa. You can imagine the sort of the tragedy of this victim of humanity's hubris roaming the frozen steppes, seeking out an African waterhole, hoping that it might see a crocodile. And it's never to be found. It'll spend its days desolate amidst a desolation.
And Tom, you talked us through a bit of the process of how this is done, but I imagine people listening will wonder how on earth you edit the genes of a wolf to do that. Just talk us through how they've done this. Did they need new technology to make it happen?
They haven't released how they've done this. There are a lot of teams looking at ways to do this. I spoke about 6 months ago to a team looking at chickens and ways to edit the chicken genome so as to make a wild chicken progenitor. But they were doing that because eventually they wanted to apply this to things like the dodo. And what you do is you've got, genetic code is just information. You look along it and you see the bits that are different in the direwolf, and then you decide which you're going to concentrate on. And then you probably use, I presume they're using CRISPR. As far as I know, they haven't said. CRISPR is a fascinating technology. It's actually a clustered, randomly interspersed... hang on. I'm going to try to remember what it was. Clustered, regularly interspersed short palindromic repeats. It originates in yogurt production. Danone, the yogurt manufacturer, were the people who really pioneered this. They spotted in bacteria these odd sections of genetic code that repeated and were quite short palindromic repeats. And then they realized that these matched similar sections in viruses. And then they worked out that an enemy recognition tool, that they had these sections of code so that they could spot them in incoming viruses, and they made proteins that went in and snipped out those bits of code. And so it was, they were basically remembering the enemy and attacking them. But what this meant was it was a programmable snipping tool. And so in about 2012, two scientists managed to find a way to harness this so that we could give it the code. And we gave it the code we needed. It snipped it out, and then you presented it with the bit of code you wanted to put in there. And suddenly, and I've massively simplified it, but suddenly you had a way of just engineering DNA.
That's extraordinary.
And so they'll have used something like this to make 20 changes in the grey wolf code, reintroducing bits of DNA that last found themselves in a fleshy mammalian package over 10,000 years ago.
You mentioned a dodo there. Just talk us through that. How do you bring back the dodo? I mean, obviously, we're going to have to change the lexicon. You can't say it's as dead as a dodo anymore. But if they did bring it back, how would they do it?
It would be very similar. I think there is a kind of pigeon that's quite close to it, and that's what they would be going for. And you would use very similar techniques. It would be easier. It's easier in birds because you can go into the eggs and do the editing. And in this case, we're talking about like just eggs that are there, not like tedious mammalian eggs or a cell that you've got to get into and stuff. I've seen pictures of it being done in chickens, and you literally just cut off the top of the egg and then stick it back on with Scotch tape afterwards.
Really?
So it's easier in those. It'd be very similar techniques.
Before we move on, I suppose I should just check, because a lot of people listening will be wondering, can they do this with dinosaurs? Is there any hope of finding dinosaur DNA under the tundra somewhere?
In science, saying no to something, there's a history of people looking like idiots. But within the confines of what we know now, I would say quite a strong no. The reason we can do this is because, or even think about doing this, is because there is a way in which these animals aren't extinct, or not quite. Their DNA persists in closely related animals. It persists in the grey wolf, in the elephant, just as Neanderthals aren't really extinct, because Neanderthal DNA persists in us. My ancestors had some rather interesting romantic choices, and so they bred with Neanderthals. And you can construct a full Neanderthal genome from the little bits and bobs that are left around in Western Europeans whose ancestors similarly enjoyed some assignations at the back of the cave. But it's also they're not extinct because their own genomes actually persist, and you can extract the fragments, put them together, and some amazing... I'm making it sound ridiculously simple. People who work in ancient DNA have done incredible work such that we can reconstruct these genomes. You can't do that with dinosaur DNA. The dinosaurs have long since... the DNA is just degraded, and there's nothing left, even in mosquitoes trapped in amber.
Even if we can't reconstruct the dinosaurs, one of the things that should perhaps worry us, one of the producers here, very astutely, I thought, said on reading the story, did they learn nothing from Jurassic Park?
Well, look, I did have a quote from a scientist who said maybe just because we can doesn't mean we should, which is very much the Jeff Goldblum line in Jurassic Park. Yeah, I mean, science has always been a battle between hubris and excitement and enthusiasm, and often the things that seem hubristic, playing God, like the first test tube baby thing,
One on
where
the
we
same
thought,
day as me.
Really?
Yeah.
Goodness. Oh, wow. Okay. That was viewed as very much within the sort of the Brave New World kind of terms, and now it's just mundane. So it may well be that we have mammoths roaming around and everyone's, yeah, of course we've got mammoths roaming around. Who knows?
Tom, the company behind this say that one of the benefits of bringing back some of these creatures would be environmental.
We're finding solutions to restore a species back to the wild. The purpose of that is to serve an ecological function. As we lose species within an ecosystem, if you think of a Jenga puzzle, you're sort of pulling blocks out of there. If we can find ways to restore animals, we can create more stability.
Just talk us through that. How on earth does that have an impact?
We are missing a lot of animals. The only continent that's got close to a proper assemblage of animals is Africa. It's got the big herbivores, it's got the big carnivores. We're missing big chunks of that. We should have the aurochs and the mastodon and the mammoth and the saber-toothed cats and all of these things. And indeed, in Australia, they should have the marsupial versions of those. But we don't precisely know how all of these went extinct, but you can trace the arrival of humans in different continents with bad things happening to big mammals correlate. But if you have these things, they can start doing interesting things. And, mammoths stamping up on the tundra and keeping down the scrub, allowing the big trees to grow, being ecosystem engineers, can end up producing more interesting, more varied habitats.
All of the elephants, almost all of them, are in some kind of conflict with some human being or other. Human beings want their tusks, or they want them to stop stepping on their vegetables. And so by moving them back up to the Arctic, with a relatively modest number of genetic changes, they should be comfortable in the Arctic. Then that gives them a whole space where there's essentially no humans and hopefully no poachers.
The canonical example is the wolves of Yosemite, where they were brought back in and that made the elk more scared, so they spent less time grazing by the rivers, which meant that trees could grow up, which meant that the beavers could come back and make dams, and you got this trophic cascade of benefits that come from reintroducing those big things that weren't there.
Quite possible that a lot of this global warming is due to our contribution to killing off a lot of Arctic mega herbivores. Yeah. There's some controversy over that, but even if it's a small amount, it could be the thing that tipped us over in climate change, not necessarily burning all the fossil fuels.
The counter-argument is they went for a reason. Until we've protected the habitats and ensured that actually they can persist in them, it's the height of human arrogance to try to undo our mistakes.
Well, on the human arrogance component in all of this, there is quite a long history of our interference in ecosystems actually making them worse. Just talk us through some of that.
Yeah, I mean, look, the cane toad was brought into Australia because it would control the cane beetles that were damaging sugar cane. It ended up not actually controlling the beetles, but just doing really, really well and eating all manner of other beetles and not really having predators that could deal with it, becoming this just widespread invasive species. So yeah, once an ecosystem's reached a balance, unbalancing it is not necessarily a good idea.
And you mentioned the ethics around this. There are huge questions about, as you said, if we can, should we? Just talk us through some of the debates going on within the scientific community around this. What are the ethical questions about whether it's right for us to be, I guess, playing God?
I mean, I hate to use the term playing God because it's misused, but there is an element of human arrogance in just deciding that it will create a species effectively, because let's not mess around, because these are species that humans like. No one is considering doing this to some random parasitic wasp that went missing in the 70s and no one's found since. This is the species that humans like, and we're doing it for our pleasure. And there's an element, this is a billionaire's folly. Then there's the wider thing that if we are pretending, and some people would argue it's pretending, that this is being done to help the animals and to improve conservation, this is clearly not the best way, they would argue, of spending the money. Really, you should just do the boring thing, which is habitat protection. Now, the guys running the company would say, but look, we're finding out a whole lot of really useful genetic techniques that could be used also for more mundane stuff. If you've got a population of animals that are on the edge, such as the northern white rhino or something, maybe this could be a way to actually bring that species back by reintroducing genetic diversity, by getting more of the species born through these techniques. And if they get this working, then you start to really have a tool that can be used to counter extinctions.
Is there a possibility that some of this technology could be used cynically? For example, in order to create a woolly mammoth, there's been talk they might have to create an artificial womb. Where does all of this go?
Yeah, look, that's the issue which we haven't even got on to. As you say, it's entirely possible, and mammoths are bigger, that this isn't something that could work in an elephant. And so they are talking about creating an artificial womb, which then you're really getting into Brave New World territory. If we have artificial wombs for mammoths, we can certainly have them for humans. That makes people feel queasy. I think people would not necessarily instantly define why they find that something queasy making, except that this is quite clearly something that could dramatically change human society with ramifications that could go in all sorts of directions.
I've heard people complain about, so for example, in China, where they have a population crisis, you could effectively create an army of people who are bred to fight, just using artificial wombs without all the relatives who rely on them and the people who they have to raise a wage for.
You'd still have to bring them up, which, you know, isn't an easy process. So, yes, pick and choose your dystopia, and this would do it. But to bring you back a bit, we don't have artificial wombs yet. This is not a minor scientific obstacle that they're talking about. So if they could create one, then yes, this would be something that would then open up a whole host of ethical worries. But that is a very big if. Even amongst the other stuff we've been talking about, that is something, it's not just, and then we do this. It would be a quite astonishing scientific achievement if they actually could pull that off. I think it also, the fact that we're having this discussion about this just goes to show how many hurdles potentially remain in doing this before it really becomes an issue.
And yet within our lifetimes, these are stories, these are developments that would have furnished sci-fi when we were growing up. Suddenly they're being talked about quite seriously. Is this an insanely interesting time to be a science editor, or is it slightly terrifying how quickly it's all changing?
It is. The genetics revolution is stunning. It's been the big story of the past 20 years, in a large part thanks to technologies like first the sequencing of the genome, then CRISPR. But in between what the genome has told us, it's told us that humans and Neanderthals and the Denisovans interbred. It's told us that Denisovans exist. We found all manner of other human species that coexisted with us. It's completely changed our view of human origins. Then we're getting all of the genetic information about diseases. Then we're getting things like the mRNA and AstraZeneca vaccines, which are all coming about because of this genetics revolution that's just going to keep on going. And now it's something that's being combined with AI that is just whooshing off as well. So, you know, who knows? If you listen to the AI people and consider what we could combine the genomics revolution with the AI, humanity is on the edge of a precipice at which anything and everything is possible. And it may just be that an AI goes rogue and uses CRISPR to create a bioweapon that kills us all, or it could be that we have a panacea for our ills.
Always the optimist. I now feel like we're only playing catch up to the yogurt, to be honest, but
we are, in a sense. That's a miracle of evolution. We are, in a sense, playing catch up to the yogurt, and isn't that fabulous?
That was the Times science writer, the inimitable Tom Whipple. As Tom mentioned, he's been covering the story for over a decade, and you can find more of his articles on it at thetimes.com with a subscription. And if you enjoyed this episode, you might want to have a listen back to Tom talking about the science of ugliness. We'll put a link to that in the description of this podcast. This episode was produced by Shabnam Grewal. The executive producer was Molly Guinness. Sound design and theme composition were by Mal Assetto. If you want to get in touch with us about this or any other subject, do drop us a line to thestory@thetimes.com. Thanks for listening. See you again soon.